Right, this video is about the gas laws, and there's multiple gas laws, and it's hard to keep it straight. Which one is which one are we multiplying, which one we're dividing? And you'll find out actually in the next unit that there's an easier equation to use. But for history's sake, we do want to recognize how we started this process of learning how the gases, pressure and volume is related as one, how their volume and temperature are related, how their pressure and temperature are related. And then somebody was able to put this together in a whole big package, which they wrote in the gas law triangle. Okay, so pressure goes in this corner. A B for Boyles goes here. Volume goes here. C for Charles. T for temperature. G for Gay-Lussac's. So that is what you're going to have right there to help you figure out what's going on. Okay, and what do we have for the acronym? Can these guys possibly be victorious? So you start over here. That's why that one has the underline in your slides. Can these guys possibly be victorious? So that's the thing to memorize if you don't have your handy triangle with you. Now, this question asks, which one is pressure and volume? Which law? So I look at pressure and I look at volume, and what goes in between tells me that this law is Boyle's law. Okay? If we're varying volume and temperature, it's Charles's law. If we're varying pressure and temperature, it's Gay-Lussac's law. So you have the name of the laws detailing who did what relationship. Now you have to know how to use that triangle to figure out what the equation is, because it's not exactly like how the density triangle is, but it is close. This triangle only gives you half of the equation, but each side is the same. Except the left is where you start, or initial, so almost like the reactants, and the right is the final, almost like the products. So you're putting together some information that you've gotten from the other chapters. You're just putting it in a much different way. So for Boyle's law, the equation would be pressure start, volume start equals pressure end, volume end. And that's how you would do Boyle's law. Charles' law, volume start divided by, because just like the density triangle, when we're down here on the bottom, that's divided by because it looks like a fraction. Picture it like a fraction. So volume start over temperature start equals volume end over temperature end. Gay-Lussac's over here must relate pressure and temperature. We remember that fraction line again. So it's pressure at the start divided by temperature at the start equals pressure at the end over temperature at the end. And then somebody came along and said, hey, I'm going to be able to put that together if I have to vary pressure, volume, and temperature. Pressure, volume, and temperature, still the same triangle, but I know that pressure at the start times volume at the start divided by temperature at the start is equal to pressure at the end, volume at the end, temperature at the end. And this is the combined law. And next unit, you'll learn the ideal gas law. What are some tricks that you have to remember here? Okay, your pressures have to match. I don't care what they are, okay, but they have to match. So they could even be in some US measurements, okay? They don't necessarily have to be in System International or SI units, but the pressure have to match the units. The volume have to match units. So that could be milliliters. They all have to be in milliliters, or they all have to be in liters, or they all have to be in cubic centimeters. Doesn't matter as long as they all match. Temperature is your weird one. It can only be in Kelvin. Okay. Temperature can only be in Kelvin. So if you have a temperature in degrees C, you got to convert it to Kelvin. If you have a temperature in degrees F, you have to convert it to Kelvin. So make sure you have those equations available and handy. And there's the gas triangle.